Today, we're going to talk about the map interface in Java, key value storage, hashing, ordering, and real-world lookups. Let's go. What is a map? A map is a data structure that stores associations between two objects. It stores key value pairs. You can think about it as a dictionary or a phone book. Alice maps to the 214 number, and Bob maps to the 972 number. But an object is not just storing key value pairs, it's storing relationships. It's storing how those keys relate to the values. Keys are unique. In maps, values can repeat, but the keys are unique. You cannot have two identical keys, but you can have multiple identical values as long as those values map to different keys. Retrieval is done using the key, and we focus on lookup, not so much on iteration. A list answers, what is at position 5? But the map wants to know what value belongs to this key. What is Alice's phone number, for example, from the last slide? A map is not a collection. It's not a collection. Why is map not a collection? A collection stores individual elements. A map stores relationships, as I already mentioned. A mapping to 10, B mapping to 20, C mapping to 30. You're not just storing objects. Actually, you're not storing objects. You're storing mappings. You're storing those relationships. Map does not extend collection, but it does have its own hierarchy. Here are the concrete implementations of the map interface. We have HashMap, LinkedHashMap, and TreeMap. Let's talk about HashMap. HashMap is backed by a hash table. Essentially, the way that a hash table backs a hash map is that each key has its own hash code. So we match the hash codes with the keys using this hash map. And each key has a unique hash code. That's how we keep the keys unique. The lookup is very quick. It's an O of 1 or constant time lookup. There's no ordering. And one null key value is allowed. HashMap is the most commonly used map. It's the most commonly used concrete implementation of map. And think about it like this. It's an instant lookup table. That's how I would think of a hash map. Linked hash map is backed not only by a hash table, but it's also backed by a linked list. And you know what happens when things are backed by linked lists. That means that that data structure is ordered by insertion order, is indexed by insertion order. It maintains insertion order. However, it's slightly slower because it has to maintain the insertion order. It's great for caching. And the way I would think of it is it's a predictable hash map. Since you know what the insertion order is, you know where the keys are going to be. You can predict it. TreeMap. So TreeMap is apparently backed by the same red-black tree that was back in TreeSet. And this tree allows sorting. You know, something about the red and black nodes that causes this self-balancing tree that sorts nodes. Anyway, I'm not going to get too much into it because that's a whole nother talk. And we don't got time for that right now. The keys are sorted because of this colored tree that we have. The operations are O of log n. So it's faster than linear time, but slower than constant time. TreeMap does not allow null keys. That's another thing about anything backed by a tree. You can't have any null values, no null keys. And because it allows sorting, it uses a comparable or a comparator, which I'll probably talk about in the next talk. I would think about this as a self-sorting dictionary. So you have key value pairs, and those keys are sorted. Like if the keys are strings, there will be in alphabetical order. Okay, we're back to our table. So this table is not really saying anything that we haven't already said. So what I'm going to do is have you pause this presentation and look at this for yourself. Just focus on the things that are colored red. Those are the concrete implementations of map. So we want to know, when are we using these maps? So maps are pretty much used whenever you have to look up anything by an identifier, the identifier being a key. So let's say you have to map a user ID to a person or an object. During a logon, you have to map a username to a hashed password. And it's hashed because you're not going to have the real username in the database. That's a security risk. Product ID to a product, and so on and so forth. So when do you choose each map? So if you need the fastest lookup, HashMap, because HashMap got the lookup. If you want to preserve insertion order, but you don't really need sorting, LinkedHashMap is for you. But if you want your keys sorted, TreeMap might be better for you. So we have all these nice methods that are unique to map. And I'm going to talk about these more in the coding portion of this video. But we have the put method, where it's essentially like inserting a key value pair into a map. And another interesting thing about the put method is if you already have a key present, but it's a different value, it's going to overwrite the value of that key. You'll see this in a minute. There's a get method. It's very similar to the get method in other collections, but you're getting by the key. You're removing by the key, contains the key, so you want to see if there's a key present or not. Contains value, see if the value is present or not. Then key set. So the key set returns a set of keys. That's why it's called key set, because the keys are unique. So it's going to return a set. Values returns a list of values because the values can repeat. entrySet, on the other hand, returns key value pairs because the keys are unique. So if the keys are unique, then the entries are going to be unique. Let's go. Hello, everyone. We are back in Eclipse. We are back in our good old IDE. Now, what you're going to notice is whenever we declare a map, so it's going to be key value. The key can be pretty much any data type as long as it's a reference type. The value can also be any data type as long as it's a reference type. So it's map, and then you have these angled brackets, key value, then you have a variable, and then new hash map. This, like these two angled brackets, the type is inferred. So if you have the type stated here, it's inferred. And then of course this map is used as a reference type. It's more abstract. It's an abstraction of this concrete implementation. Anyway, enough about the quasi-philosophical nature of maps. Let's talk about the exercise. So here we're inserting 4 values. So we have these 4 students that are being added to the grade book. Let's run this and see what we get. Let's make sure I save this. All right, we're saving it. Let's run this, see what we get. So initial grade book. So we have, and notice one thing. Notice that there's no order. Like it's unordered. Even though we inserted Alice first, she's like way over here. Alice is way over here. She was inserted first, but she's way over here. Charlie was inserted third, but he's last. So as you can see, a hash map is not ordered. All right, let's comment this out. Okay, now we're going to perform a lookup. So we're going to use the get method, and we're going to get Alice. So we're using the get by the key. So when we get this, it's going to return Alice with a value of 90. So it's going to return this entry. So let's run this and see. Oh, you know what? You know what happened? I commented this stuff out too. Of course, it's going to be null. Had a long day at work, so forgive me. There we go. So her grade is 90. Okay. So it returned the value. I said entry before it's the value. Okay. So let's comment this out. All right. Let's comment these in. So we're going to update the value. So what you're going to notice is that you're going to overwrite the old value of Bob. So Bob, it looks like Bob took a test. He got an 85. He's like, you know what? I need to do better. I want to do better. So he retook the test and he got a 95. So now we have to reflect that value by updating it. Okay. So it looks like he retook the exam and he got a 95. So good job, Bob. But we're done with you. So let's comment this out. Okay. The next, we're going to use the contains method. So we have the contains method here, and it's Charlie in the class. So we just want to make sure Charlie showed up. You know, maybe he's one of these dudes that like to skip class. So we got to make sure he's here. And then Eve, we're looking for Eve, but I have a feeling that Eve is not going to show up. So let's run this and see what we get. Okay, so Charlie's in class, but Eve did not even show up. I mean, she was never really enrolled, so I mean, he can't really be mad. All right. Okay, so now, now we're going to remove it, we're going to remove somebody. So Charlie, he got a 78 on the last test. He's a bit of an overachiever. He's kind of like screw it, man. I don't need this. So he's just gonna leave. He's gonna bounce. Anyway, let's run this and see what we got. So so it looks like Charlie is no longer in the class. So it's hard to say goodbye, but Charlie had to do what was best for him. Okay, the next one we're going to iterate. So we're going to iterate. We have different ways to iterate through a map, so to speak. So what we're going to do here is we're going to get all the entries in this grade book. We're going to print the key and the value. So we're going to print the key pointing to the value. So let's do this. Okay. So we printed all the keys, all the values. Oh, and it looks like Charlie is back. So good for him. All right, let's move on to the next. So we're going to iterate through, and we're going to look for the keys. So we're looking through key set. Last one was entry set. So we're going to look through the set of keys. So remember, the key set method returns a set of keys because each key is unique. So let's see what we get. Okay. So all the keys are here. So we will comment this out and our values. Let's print out the values in this map. So let's go. All right. So we printed out the values. Let me try something here. Let's see what happens if I add somebody else. So let's see so Eve. So let's add Eve. So we'll add Eve just to see what happens here. So let's run this. Okay. So it does print duplicate values. So it's printing a list. It's going through a list of values. I just kind of feel like it's probably something important to know. Okay, let's move on to the next one. So this one is the frequency counter. Okay. And this one you should pay special attention to because this is a coding type of question. Like, those like leak code kind of problems, those like interview coding kind of problems. This is one of them. This is a common one. Like any boot camp, yeah, anybody who's teaching you anything about maps is gonna have a scenario like this. So essentially, what we're doing is we're we're looping through and seeing how we're looping through and we're counting the frequency of these names. So Alice appears 3 times, Diana appears twice, Bob appears twice. So what we're doing is we're creating a map. So each of these names will map to the number of times they appear in this string array. And the way we're doing it is we're looping through the admissions. We're using the put method to add this key, and then this getter default. This is a method that wasn't specifically covered before, but this getter default is basically if the key exists, then get the value of that key. If the key does not exist, create create the key and assign a value to that key, which is a 0. So when it loops through the first time, Alice, when it loops through the first time, Alice is not assigned yet. So it's going to assign Alice, and then this getter default. So Alice is not here yet. So it's going to add a default value of 0 and then add 1. Anyway, let's run this. Okay, so it looks like Diana appeared twice, Bob appeared twice, Alice appeared 3 times. All right, I think we're done here. It's been a pleasure, but I have got to go. Peace.